Hello and welcome to AI Insights. Today, we're diving into the fascinating world of cognitive architectures in artificial intelligence. Think of these as blueprints for creating AI systems that can reason, learn, and adapt much like our own minds. The goal is to build AI agents that don't just crunch numbers, but can process information, make decisions, and interact with their environment in increasingly human-like ways. At its core, a cognitive architecture is a theory about how the human mind works, translated into a computational system. These frameworks typically include several key components. First, there's perception, which allows the AI to gather and interpret information from its surroundings. Then, we have memory, similar to ours, with both short-term working memory and long-term storage for knowledge. Reasoning and decision-making are crucial, enabling the AI to solve problems and plan actions. And finally, learning, which allows the AI to improve from experience. There are a few main types of these architectures. Symbolic architectures, like ACTR and SOAR, model thought using explicit rules and structured knowledge, often using if-then statements. Then there are emergent architectures, often based on neural networks, where complex behaviors develop from the bottom up through experience, much like how our brains learn. And increasingly popular are hybrid architectures, which try to combine the best of both worlds, the explicit reasoning of symbolic systems with the learning strengths of neural networks. So, what's new in this field? A big trend is integrating cognitive architectures with large language models, or LLMs. The idea is to use the architecture's reasoning skills to guide the vast knowledge of LLMs, potentially making AI more accurate and less prone to errors. There's also a big push for more sophisticated learning and memory systems, and importantly, for explainability. If an AI can model human-like attention and reasoning, it might be able to explain its decisions more clearly, which is vital in fields like healthcare and finance. Neuro-symbolic AI, that hybrid approach, is also gaining a lot of traction. Cognitive architectures aren't just theoretical, they have real-world applications. In robotics, they enable more autonomous navigation. In healthcare, they can assist with diagnosis or even personalize mental health therapy. Autonomous systems like self-driving cars rely on them, and they're helping create AI assistants that can hold more natural conversations. But there are still challenges. Building systems that can handle real-world complexity and scale is tough. Seamlessly integrating different cognitive functions is another hurdle. And while the aim is to mimic human thought, truly replicating the flexibility and common sense of human cognition is still a long way off. Training these models also often requires huge amounts of data, and we must ensure these advanced systems are ethical and free from bias. The future, however, looks promising. Researchers are working to develop more powerful and trustworthy AI by drawing insights from cognitive science and neuroscience. The ongoing refinement of cognitive architectures is a key step on the path toward artificial general intelligence, creating machines with human-like cognitive abilities across a wide array of tasks. It's a complex journey, but one with the potential to revolutionize how we interact with technology. Thanks for tuning in to AI Insights.